And that's our first step towards the syllabus. All right, that we're going to understand what your assessment objectives are. Okay, very simply, let me just erase the graffiti on the side. If you look at the first one, it is undoubtedly simpler to understand. It just simply says that the first assessment objective is knowledge and understanding of mathematical techniques. Okay, this my first and foremost. By your understanding, what do you think this means? Yes, I don't expect you to, give me a definition of some sort, but like, what do you think that this could possibly mean? Yes.
Maybe it means that the like instead of like just knowing the question, you have to understand what the question asks. So
Okay.
sometimes in the question you have to think outside the box because maybe it's not that straightforward.
Okay. Okay. Good. Anything else?
No, no.
All right. That's perfect. Whatever you said is absolutely correct. That is a, a part of this means what you've absolutely said, that this is like knowledge and understanding of mathematical technique. Whatever technique that you're going to apply to the question, you need to, the first thing is to have knowledge regarding it, to know when to apply what, all right, or to understand what the question is asking from you. Same is the case with understanding of mathematical technique. You need to understand it as well. If you are unable to understand why or when you're going to, apply a certain technique to a particular question, you won't be able to, solve the question as to how the examiner wants the question to be solved. And that is where you're going to lose out marks as well. Now, you might even get the correct answer, but you will still only get like 1 mark for the answer. The answer is only worth 1 mark. The rest of the marks are an accumulation of your method marks, your working, everything else. All right, Vishnu? So your knowledge and your understanding of mathematical technique needs to be spot on. Now the examiner's done us a favor. He's actually, showed us what could possibly, what could he or she possibly mean by this. They're saying that candidates should be able to recall and apply mathematical knowledge and technique. Okay, this is exactly what you're saying. Like whatever you've been taught, you should be able to know the technique. You should have knowledge of it. And on top of that, there should be some profound understanding of that particular technique in order to, apply it successfully. Clear, Bisma? So this is just recall and apply. Recall in the sense, now, this is very important. This word itself is extremely important because this actually tells you that the examiner is not like, okay, assistance will be provided to you in the question. You will have to read off um, which technique you have to apply, or the technique or the formula that you have to apply will be given to you. No, they're saying recall. That means that there is a pre-existing expectation from the examiner that you have been introduced to a certain technique and you're able to memorize it, or you're able to understand it, store it, whatever. And at that precise appropriate time in a particular question, you're able to recall it. So the examiner is expecting you to know that. Clear? For example, if the examiner was not expecting you to know that, he or she would simply say, read off the formula or read off the technique from the formula sheet. But the formula sheet is inconclusive. It does not have a lot of formulas. The formulas that are there are pretty generic. Some area formulas are given, probably an equation solving formula is given. But the examiner's main focus is on recall. You need to, that's the first thing. Students who think that, we could solve the paper like this, we could solve the questions like these, maybe attempt it like this, there's an easier way of doing this. That's all, well and good. But the first step is to actually have the information that is required. especially all the formula, all the theorems, all the properties. And on top of that, the ability to retain them as well as recall them at the right time. Share this one. And obviously application. Application, obviously, once you're able to recall something, if it will be a shame if you're not, like able to apply it correctly. But recalling will give you a method mark. If you're able to recall the correct formula, write it down in the question, the examiner is going to give you a method mark. Regardless of whether your answer is correct or not, whether you did some working error, obviously there is a chance that you might commit some sort of plus minus mistake, some sort of arithmetic mistake. So those aren't accounted for. Just knowing what to do and showing that you know what you're going to do is enough in the sense that it's going to help you avail that method now. Clear this one? Any question?
It's all clear.
Excellent work, this one. I know this is a bit it might be a bit monotonous for you. We might have done this before as well, but this is extremely important. Whenever I begin a newer session or whenever we begin classes from scratch, this is always kept as the first class. The reason for that is you, you should have a certain mindset before actually studying the content. This should not come to you as a surprise once you're done with the content or while you're doing the content. The content, obviously, that's like, a major portion of your grade. But the ability to understand and the ability to know what sort of expectations the examiner has from you is also, like a big deal. Clear this one? Secondly, it says carry out routine procedures in mathematical and everyday situations. That is simple. Routine procedures are, you could simply include the arithmetic operations in there. Arithmetic operations are the plus, minus, multiplication, division. All those operations are included in, routine procedures. There's nothing out of the ordinary. You've been doing that for a very long time. At the same time, everyday situation. Sometimes we see questions that we can, relate to. The examiner puts the question in such a way that it feels, some sort of a real life scenario is given to you or a real world problem. Clear? Secondly, understand and use mathematical notation and terminology. Now, this is very important. Understanding any idea what could this possibly mean, this one? Yes, this one.
Um, it means like when answering the questions, like for example, in rotation, you can't just use like random words. There are like certain terms that you can use.
Okay, yes, you're right, you're right. You have to use certain terms or you have to use certain signs to get your word across. Always remember, whenever we're doing math, it is always going to be the case that mathematical notation, mathematical terminology, it's going to be equally important as the content as well. Why? Because when the examiner is going to ask you to use mathematical notation or to use terminology, or if even if the examiner doesn't ask you to do it, what if the examiner uses it, themselves? Then you're going to be in a pickle unless and until you understand, okay, that this certain notation means this, therefore this sign means this. Clear? This is extremely important. You're trying to convey to the examiner, instead of writing it down in English, for example, you're trying to convey your message to the examiner by using particular signs and particular, notations and terms. Stuff like tangent, stuff like, the signs for parallel lines. More often than not, uh, what you may call, when we're talking about, a particular question, students often find it difficult when it's perpendicular. When two lines are perpendicular, like for example, A is perpendicular to B, there's this inverted T sign in the middle, like this. Now, many a times I've had students struggle with this. They are unable to understand what could it possibly mean, and it's given in their question. And then the bigger problem comes that they're unable to comprehend what the question is saying. Or even if the question, this small aspect of the question is a part of a bigger statement of the question, they're unable to, use that particular statement to their advantage while solving the question. Those big questions regarding geometry, 5, 6 markers, where you find the lines, the tangents, and the radiuses, and there are chords. These are all technical terms. These technical terms, we might not use them in our daily life, or you might not even use them outside of math. But over here, they mean a lot. Your properties are derived from this. We say that any line coming from the radius is going to bisect the chord and at a 90-degree angle as well. So, these properties, these chord and, stuff bisecting each other, as well as notation. Notation is extremely important. And one chapter that is heavily built on notation is, set theory. Set theory is, you need to know whether it's a complement, whether it's a member of the set, what is A union B, what is A intersection B, what is A union B complement. So even though it feels like, if you look at from a layman's point of view, this probably doesn't mean anything. But to us, it's going to mean a lot when we're going to be attempting a question. Same goes for probability as well. There will be notation and terminology there that will be harder to grasp. Clear? Also, if two lines are given like this and they have these two signs, that means that the lines are equal to each other. Now, that is a notation and a term that is, you need to understand as well as use. In due time, the examiner is going to expect you to use them as well. Leaves a very good impression on the examiner. If you're answering, instead of writing an entire paragraph, okay, I think that these lines are parallel because A, B, and C are equal and whatnot. Instead of doing that, I can just simply wind it up into, you know, two sentences, writing it down like A, B is parallel to C, D, and whatnot. Clear this now?
Yes.
Now, the fourth point in your assessment objective, perform calculations with and without a calculator. Essentially, this they've tweaked it a little. Before the syllabus changed, before essentially the paper pattern changed from 2024 till 2024 actually. The paper 2 was also a calculator based paper. So, the examiner was expecting you to do your calculations in both paper 2 and paper 4 using a calculator. But now, what's going to happen is that now the examiner is expecting you to perform calculations with and without a calculator. Emphasis on without a calculator since paper 2 is now completely without it. Obviously, questions will be adapted in a way that they won't require a calculator to that extent. But students who make the calculator a liability in the sense that if they're trying to calculate 2 plus 2, or if they're trying to just, do very random and very simple calculations on their calculator, I understand while doing practice that it's easier to check and it's easier to get the correct answer and it's convenient as well as it's effective. But at the same time, paper 2 is non-calculator. So Bisma, if you're using the calculator to an annoying extent, essentially, like if you're using it to a lot, you will automatically find paper 2 difficult because of the simple fact that you will feel as if you're under equipped to sit in the exam. Why? Because you don't have the assistance of the calculator. I don't want you to make the calculator some sort of a crutch, as in that you cannot even do math without it. Clear? I want you to make sure that you're using the calculator to, you know, to check your answers and even to get your answers. But it shouldn't be so that you feel uncomfortable without the calculator. You shouldn't be not, you should not be able to, like be afraid of a particular question just because your calculator isn't there. Clear? Why? Because I've seen students struggle with paper 2 because of the fact that they feel it's more so psychological because their preparation is there, the formula isn't there on the calculator, they're just checking the answer there. They know how to put everything in. But since they've been using the calculator for so long, paper two seems difficult since it's like completely without a calculator. Clear this one?
Yes.
Okay. So now what I want you to do, I want you to develop this in your practice as well. Even if you're doing like small questions, try to do the question to the extent that you can do without the calculator. Don't be like, 2 plus 3, I'll just check it on the calculator. I'll tell you, even I do that. That's like very common knowledge because it's something that can be taken advantage of. So why not do it? But extra dependency on the calculator is never going to be helpful. Clear? And obviously, with calculations also comes with its own, pros and cons. If you're performing with your calculator, you need to make sure that you're putting in, when we're writing it down on paper, it is also criminal to miss bracket signs and to miss plus minus signs, but you can still get away with it. It's a careless mistake, but you'll still lose marks if you not fail to put the bracket or anything. If you do that on the calculator, you're just going to get the wrong answer. The calculator won't be able to auto correct itself. I'm afraid calculators haven't been. I don't think I've ever seen a calculator who can do that, but if they do make the calculator like that, maths would be so much easier. If it could add the brackets and everything, if the calculator could see what you're thinking, because it's very different to as to what you were thinking and as to what you wrote down. Clear? Okay. Look at point number 5. Organize, process, present, understand information in written form. This is kind of like we think that you are able to process that. If a histogram is given to you, or if a table is given to you and they ask you to formulate a histogram, they'll also be expecting you to have what you may call the what's it called? Frequency density. They'll the examiner is going to be expecting you to know how an histogram is formed. But the examiner is only going to give you a certain table or a certain graph or some sort of written form even. Sometimes raw data is given to you as well. So how you're going to make that raw data, how you're going to calculate mean, median, mode for that raw data. This is just your processing and organization skills, as well as organized data. Sometimes the examiner might ask you to fill a table, stem and leaf diagram, that kind of stuff. Clear, Bisma? All right. Any questions up to this point, Bisma?
No, it's not clear.
Perfect. Okay. So look at this one. Estimate, approximate, and work to degrees of accuracy appropriate to the context and convert between equivalent numerical form. Okay, now this is extremely important. Bisma, any idea what does this mean? Like up to this point, what do you think this means? Yes, Bisma. Any idea what does this mean up to this point? Appropriate to the context? Yes, Bisma.
Maybe it means that, for example, when they ask me the question, estimate maybe 2 decimal points, you have to do exactly 2 decimal points, not less or not above 2 decimal points.
Yes, you're right. You need to do some sort of conversion, degree of accuracy, estimation, approximation, anything of that sort. And that needs to be appropriate to the context. For example, if they ask you for significant figures, it is going to be extremely different as compared to the decimal place. Clear? Significant figures and decimal points are completely different. So if you're estimating to decimal points, that will be very, very different from significant figures. Clear? Same is the case over here. They're saying convert between equivalent numerical form. Equivalent numerical form. For example, mix fraction, improper fraction, decimal, writing down in third form, and what's going to happen. Understand and use measurement systems in everyday use. This Bismarck is very simply what you may call understand and use measurement systems in everyday use. So what's going to happen is that this is kind of like the day-to-day everyday conversions that we do, meters to kilometers, kgs to grams, centimeters, millimeters, stuff like that. Clear? Keeping that in mind, so this will be its own what you may call this will be its own chapter essentially. We will go through these conversions, how to, but we won't go them individually, like, first let's do the length conversions, then do the time conversion. No, it will very simply be going from a smaller number to a larger number, or from a smaller unit essentially to a larger unit, or from a larger unit to a smaller unit. Clear? Keeping that in mind, measure and draw geometrical instruments to an appropriate degree of accuracy. Measure and draw using geometrical instruments. What do you think these geometrical instruments could be? Yes, Krishna. Any idea what do you think these geometrical instruments could be?
Like a ruler, a compass, a protractor.
Yeah, that's absolutely the case. A compass, a protractor. You know those angle bisector, perpendicular bisector diagrams they ask you. They tell you to do, like, the bearing stuff. All right. Sorry, I'm a bit distracted right now. There's a fly here that I want to kill, but it's like flying away over my head all the time. I don't know where did it go, but it's like extremely distracting. Sorry. Yes, Vikram. So we're at the last point. Recognize and use spatial relationships in 2-3 dimensions. First of all, can you tell me what does this mean?
Spatial come from the word space.
Nice. Your English. Nice. Your English is amazing.
But I don't know what it means by spatial relationships.
Spatial relationship. Okay. Like, for example, it is spatial comes from the word space, right? So, are they taking us to outer space? Like, what sort of things are they saying? Yes. Hmm? Yes. Hmm. Yes, Krishna. Are they taking us to space? Is the trip included in the syllabus? Spatial relationships are your ability to understand the relationships in space around you. In space around you in terms of area, volume. How? 2D, 3D. 2 dimensions, 3 dimensions. 2 dimensional, you will calculate area. 3 dimensions, you will calculate volume, surface area. Stuff like that. Clear?
Yes.
So what's going to happen is, and what will be included over here? I'll break it down to the extreme. Over here, the examiner is talking about transformation, symmetry, coordinates. You know how you're going to transform them, rotational symmetry, spaces, right? Your ability to understand relationships between 2 points that have been transformed, stuff like that. Clear? And have you? I think you've seen those. This one, have you seen those questions where they give you a 3D shape and then they cut it and they give you a part of it and they ask you to calculate volume or stuff like that? That visualization is your ability to recognize and use spatial relationships. Is this clear?
Yes.
That is how it is. Like, for example, angle of elevation. At times, they give you a shape, what you may call, this is like a shape, this is a hideous looking shape. But they sometimes simply tell you, Okay, the angle is between plane AB and plane XY, the angle in between. This is the recognition and the using of spatial relations in 2D relations. Clear?
Yes.
Yes. So that your ability. Now, this is where visualization and understanding. This might, if you just simply be like, okay, I'll just see the question and won't be any imagination or visualization, things are going to be very difficult. How? What's going to happen? One, two, three, four. Now, what's going to happen is, for example, these planes. Now, if they're asking for the what you may call the if they're asking for a particular angle, so what's going to happen is that those spatial relationships you need to understand how different angles will be situated at which vertices, which corners, stuff like that. Clear, Bisma? So your visualization and your ability to imagine stuff, because on paper the examiner can only help you to a certain extent. If the diagram is given, sure, it will be nice, but the issue will lie entirely. What is going to happen is that the issue will lie entirely that if the examiner does not give the diagram, if the examiner only gives a statement, then the entire burden is on your visualization, your ability to recognize and understand whatever fancy word this is, spatial relationship. Clear, Bisma?
Oh, yes.
Excellent. AO2 is now. So we're done with the first uh, assessment objective. We can do the second one, AO2. Clear? Analyze, interpret, and communicate mathematically. Okay. Secondly, we need to understand is that we probably won't have a lot of time to, go through all of them, but we'll, begin them and see how many we can do. AO2 is analysis, interpretation, and communication mathematics. Clear? So AO2 is analysis, interpretation, communication mathematically. Candidates should be able to analyze a problem and identify a suitable strategy to solve it, including using a combination of processes wherever appropriate. Where appropriate. Analyze a problem which is a suitable and identify a suitable strategy to solve. This one, many a times we've seen questions which have 6, 7 marks and like a lot of marks essentially. And there's only one, two statements given regarding the information, probably a small diagram that is, very scarcely labeled. And the examiner expects you to do like calculate one aspect of it. The first thing is identification of the problem. That is what I tell you all the time, that whenever the examiner says calculate X, you need to label X on the diagram first. Analyze where the problem actually exists. Clear? And then identify a suitable strategy to solve it. This is extremely important. The identification of a suitable strategy to solve it is so important. Clear, Bisma? Including a combination of processes where appropriate. Including, now, it also says a combination of processes where appropriate. So sometimes it will be the case that you might have to calculate the gradient, then you might have to calculate some other gradient, then you get to the answer or something of that sort. Other times you might have to take derivative, then find the equation, stuff like that. Clear? So analyze the problem, identify a suitable strategy. We analyzed, okay, this is where X is. That's how we're going to find it. Identify a suitable strategy. Okay, I could use this or perhaps that to solve X. And sometimes I might even need to do 2, 3 steps to get to the answer. Or I might need to combine 2, 3 processes. Perhaps use completing the square as well as differentiation to get to the answer. Might have to use sine cosine trigonometric ratios. And on top of that, might have to use cosine rule, for example, if there's a larger triangle as well, or if there's a separate shape. Clear? Might have to use two, three different angle properties and geometric properties. Clear, Bisma? So
Yes.
that is how it's going to be, where appropriate. Secondly, make connections between different areas of mathematics. Make connections. What do you think this means, by the way? Make, make connections between different areas of mathematics. Yes, Bisma. What will it be?
Um, it maybe means that, for example, there are two different topics of math, and they do not like align with each other, but there's still a connection between them.
There is still a connection between them. That is absolutely what it means. For example, Vishwa, set notation, Venn diagram that are also used in probability. Clear? Trigonometry with geometry. Algebra with trigonometry. Algebra with geometry. Algebra technically goes with everything. Indices and surds. Connections, they are two different topics. Indices and surds, you can say that they could even be counted as a single topic. But still, your ability to make connection is going to be extremely important. Two different topics, if they're given at the same time, you need to be able to identify and separate them. Why? Because only then you will understand, okay, I could probably use a formula from set notation as well as a formula from probability. Clear, Bisma? Next up, you have recognition of patterns in a variety of situations and make and justify generalization. What do you think this means? Yes, Bisma. What do you think this means? Recognition of patterns in a variety of situations and make and justify generalization. That's weird, no?
Um, I think what it means is that sometimes people, when like solving the paper, they find like a pattern in the answers, maybe
They find the what? Sorry, could you repeat that?
like a pattern in the answers.
Exactly. There will be a pattern in the what you may call um, um, certain patterns in the question. Perhaps uh, you could be given a question in which you have to use a series of um, formulas in a particular order. And perhaps, like, for example, transformation. Sometimes you have to, like, if it's combined transformations one after the other, you need to identify, okay, which one could be first. And making and justifying generalization. Sometimes we take things as for granted and we generally make assumptions. Even though I simply tell my students to not make assumptions, sometimes it's like literally staring at us in the face. And your ability to make a generalization and your ability to justify a generalization, if you yourself made it or if the examiner has made it. Like if the examiner is taking something for granted, like this is just general information. You need to be able to justify and also make those sort of you need to be uh, prepared with the content enough so that you are even able to make these generalizations. Clear, Bisma? Secondly, make logical inferences and draw conclusions from mathematical data in this. This is kind of like, do you take English as well, Bisma?
Yes.
Okay. I don't know about you now, but back when I was in my O level, we used to have a comprehension passage in English. Do you guys have that too still or no?
Yes. Yes.
Yeah, you guys. I'm not sure about how you guys have uh, what you may call. I don't know about English language now, but at the same time, your logical inferences and strong conclusions. It's kind of similar to how those English comprehension paragraphs, where one line is given and a question is given, and you're able to draw a conclusion. Okay, this is what the writer or the author meant by it, and this is what they're saying. This is what actually what it's saying. The examiner is going to give you some data, or the examiner is going to write down a statement. You need to identify an inference, logical inference, okay? Something that is mathematically accurate. You need to conclude from it and move forward. Sometimes the examiner gives you like, certain data. Normally, this is included in what you may call, normally this is included in stats. Normally this is included when we're doing stats, where, like, uh, statistical data is given to you. They might even tell you what is the mean, median, averages, stuff like that. And they tell you, okay, what if we add something? What could be disadvantages of the mean? What could be advantages of the averages and stuff like that? So that is what's going to be the case over here. What you need to identify and what you need to conclude from the given data. Communicate methods and results in a clear logical form. Communicate methods, results in a clear. You need to make sure that the answer that you've written actually looks like the answer, actually resembles the answer. If your answer is all over the place, if you're doing your working and you maybe float your answer over here, the examiner might even check it. The examiner might even give you the full mark for it if it's correct. That's the first thing. But it's emphasis on the word clear over here. Your result and your answer and your methodology should be clear and logical. Obviously, it has to be logical, otherwise, it won't be correct. But it needs to be clear. Is this clear?
Yes.
Okay. Lastly, Bisma, interpret information in different forms and change from one form of representation to the other. What do you think this means? Yes, this one. Interpret information in different forms and change from one form of representation to the other. What do you think this means?
I'm not sure.
Bisma, if your answer is insert form, can you write it in indices form? Yes. You should be able to know how to do that. Secondly, if your answer is in decimal, you should be able to write it down into a fraction. If they want the exact form, you need to be able to write it from indices to third. Interconversions of your result. Interpret information in different forms and change from one form. If something is written in third, I should be I should be aware enough to convert it into indices. And if I'm writing down the answer in thirds and the examiner wants it in some sort of an indices answer, if I leave it in that third form, I'll probably get marks, but I won't get the full mark. Probably get like 1 or 2 marks less. Why? Because the examiner has specifically said that he or she wants the answer in a particular form and I'm ignoring it. Clear, Bisma? So these interconversions and your interpretation, the examiner could give you a trigonometric question with, sine, cos, tan, whatnot, and your ability to convert from them, go from sine to cos, cos to tan, whatever. So those will be extremely important as well. Think of it as a language. In English, you convey what you're trying to say, right? Same goes for other languages. You could do the same in Arabic. You could do the same in any language in the world. Math is kind of like you're trying to communicate and you're trying to convey your message or you're trying to get your point across in terms of numbers, variables, terminology, signs, notation, stuff like that. Clear, Bisma?
Yes.
Perfecto. Alrighty then, Bisma. That will be all.